Thank you all for coming to our talk today. My name is Thomas Park. I'm a software engineer at Google. I work on Google Cloud Platform and specifically on BigQuery. I'm here with Felipe Hoffa, a Google developer advocate, and we're going to be telling you about a feature that I'm very excited about, which is the ability to run JavaScript functions over your data in BigQuery. So quick agenda. We'll tell you a little bit about what BigQuery is, for those of you who may not be familiar with the tool yet. Then we'll take a look at a couple of examples of things that don't fit well with the SQL processing model and cases where things like user-defined functions really come in handy. We'll take a couple of minutes to look at the implementation and dig into some details under the hood, and then look at another kind of more involved example. So for now, I'll hand it over to Felipe to tell you a little bit more about what BigQuery is.
Thank you, Thomas. Hey everyone, Felipe Hoffa, developer advocate at Google San Francisco. First question, who here knows what BigQuery is? Okay, I see some hands. Not everyone knows about it. So let me quickly introduce you to what BigQuery is. Very quickly, let's go over this slide. BigQuery is a cloud analytical database. It's run by Google. You don't need to run anything. Everything is on Google servers. And if you want to analyze data, you can load your data into BigQuery, and BigQuery will analyze it really, really fast. It runs over SQL, so you already know, most of you might know how to run SQL. Who here works with big data? A few hands. Who here knows SQL? Yeah, everyone knows SQL. Now, who has ever had a SQL query that takes more than 10 minutes to run? An hour? Yes. Yes. So maybe you are working with big data. Maybe you need a faster database that would run the same queries in seconds. And BigQuery does this, running full table scans over all your data in seconds. It has a REST API. It's always on, so you don't need to configure servers. You don't need to worry about how much time it's running. It's always running. And the only two costs are storage, how much data you are storing, and queries, how much data you are querying. It has SQL. You have a free terabyte every month to query over public data and or your own data if you are uploading it. And I could talk for a long time about what BigQuery is, but let me show you a demo so we can clearly go through this. Everyone knows Wikipedia? Yep. How many page views Wikipedia has in a month? Any guess? I want to hear numbers. How many? Couple billions? Couple billions, sounds good. The good thing is I have all the Wikipedia page views stored in a table in BigQuery. It's an open table. Anyone can come here and look at it. And this table has, as you can see here, 5 columns that basically say how many page views each page on Wikipedia had during an hour. So that's the title.
Well, you can see it's about 400
I lost my 5 columns. But you can see that this table has 400 gigabytes of data. This, I have here only the August 2014 data. And it has 6 billion rows. So Wikipedia has much more than 6 billion page views during August because each column is counting the number of, so each row has a number of requests that any particular page on any Wikipedia language had during that hour. So if we want to know the exact number of page views Wikipedia had during August.
So I'm sorry, we heard a guess of 6 billion earlier? Let's take another guess. How long is this query going to take to run, scanning all 6 billion rows? Any guesses? 15 seconds. Okay,
15 seconds.
Let's
run it. Simple SQL query. It will look over 6 billion rows and do the addition of it. 9 seconds.
9 seconds.
Yeah, and the result is 54
billion. Oh, wait a minute.
Billion.
Yeah, 54 billion rows.
54 billion rows.
Views, sorry.
Views. 54 billion rows during August. But we can play further with this. I might have this number previously stored. Let's try to run a regular expression over these 6 billion rows. Any random word? Sorry?
Football.
Football. Let's try football. But let's try a regular expression with football, anything that, so we have the title, anything that starts with F, dot star, and ends with L. Let's run this query. In this case, I'm going over the 6 billion rows, and I'm only counting the ones that match this regular expression. And again, the query should run fast. It's taken.
Of course, being a multi-tenant service, this is running on the live production server, not a special demo instance that we've set up just for this. So query times can vary a little bit.
Yeah.
But 22.
It also depends on our cloud connection. So I always blame Wi-Fi when it takes so long in a conference. For me, this is long, 22 seconds to go over 6 billion rows running a regular expression.
But we can also look at what some of the titles are here.
Let's see what the pages are actually. So we can group by title or by the first column. And let's order by the second column in descending order. Let's have a limit to only get the top 10. And again, you can run any arbitrary query you want. They run super fast. They go over your data, public data. If you have your own data, it's super secure with strong security controls. And if you have public data, you can share it with anyone instantly. And, well, it's taking longer than usually, but there it is. So for that regular expression, the most viewed page was James Foley, folklore, James Foley. And maybe if we keep going down, we will find football. These are the results we got. Now, if you're wondering, how does it run this fast? I brought a little diagram here. Here we have the query we were running, and we have all the data stored in distributed storage. We have a massive storage space. We store all the data in columns. So whenever you run a query, the BigQuery only has to go through the columns you specify. In this case, I'm looking at the title and the request columns. And those columns will be scanned fully. So what's the fast way to go over terabytes of data in very few seconds? Well, you simply put a lot of computers reading it in parallel. How many? It all depends on how much data you have. The thing is with BigQuery, you don't need to care about that. We just try to keep the time constant as much as possible. And all these computers are reading the data in parallel, and they are processing it, and they start filtering out wherever matches or doesn't match the regular expression. This data gets passed on to further servers on the tree that collect this data, they group it, until everything ends up in one root node that collects all the data, reduces it, and sorts it and mixes it out. This is super cool. There's a lot that you can do with SQL. Most of my problems are solved with it. But sometimes we have problems that are not so simple to solve. We wish we had a more of a procedural language to solve them. And for that, Thomas has a solution.
Excellent, thank you. So we'll take a look at a problem that comes up not uncommonly, which is analyzing data across rows. So let's think about this scenario. We have door access records from a very well-secure lab, such that you need to badge in whether you're entering the lab or leaving. So every time you cross the door, you have to badge in. What this turns out to be is a type of time series analysis over discrete user action data. Now here we're talking about a secret research lab because it's kind of fun to talk about secret research labs, but you can also imagine this in the context of users taking actions on your website or users interacting with your software. So let's take a look at what the data here looks like. User comes into the lab, scans in at 9 o'clock in the morning, we get one row, they leave to go do something, 10 o'clock, we get another row, and so on and so forth throughout the day. Now, the question that I want to ask is how much time did each user spend in the lab in total, where we have this shape of data where every action is represented as a discrete row? So who here has had to do analysis on this type of data or data with this shape before? How'd it work out for you? Kind of, sort of? Did you end up finding a solution in SQL, or did you end up exporting it to an external processing environment? They use Cassandra. Perfect. Okay. So one of the things that makes this kind of problem really difficult is that we basically want to look at independent rows of data as if they're a part of a collection. So here, for example, we want to see that between the first and the second row of data, there's about 60 minutes in this interval. And then between the third and the fourth, there's 105, and so on and so forth. And for this query, we would want to sum these all up. Now, this is tractable if you have a small amount of data, but what happens when you start having millions or billions of records that you need to deal with? And then further, you want to subdivide it up by day, for example. It gets really horrible really, really quickly. So as programmers, one of the things that we might like to do in a situation like this is collect all of the data that we care about into a collection, so something like an array. It just so happens that BigQuery has the ability to do exactly this. We can look at data across rows and collect it into a format like I'm showing here. This makes it much, much easier to deal with in a programmatic fashion, maybe not necessarily in raw SQL, but with this kind of format, we can iterate over the values in the array and compute the total time that we're looking for. Now, BigQuery has a nifty feature called Nest, which actually will look across rows of data and basically create an array with with repeated elements of whatever you're trying to nest on. So in this example here, I'm nesting by the user ID and getting the timestamps for each user in the data set in a repeated field. Now, of course, this talk is about user-defined functions in JavaScript, so it follows that we can do the analysis that we're looking for with a JavaScript function. It's pretty straightforward. Basically, it's just a for loop over the data. This is pure elementary computer science. The only thing that I should point out here is the sorting that happens in the middle. Due to the distributed nature of BigQuery's computations, some of the functions operate on shards that get propagated up the tree in a way that has some peculiarities to it. Nest is one of these in that the ordering of the elements in your array produced by Nest is non-deterministic once your results get to a certain size. And that certain size is a very fuzzy boundary. So basically, if you depend on an ordering of the elements in your array, you need to sort them, which is what we're doing here. But all in all, it's pretty straightforward. So let's look and see how you actually plug this into your queries. Ta-da! So there's a good amount of text on the slide here, so I'll walk through it piece by piece. What we have here is the JavaScript function. This is basically the function that I was showing on the previous slide, just condensed a little bit. For the input, you need to tell us only the input column names that you're interested in. This is because your data is coming from BigQuery. BigQuery knows what the types of your data are, whether it's a table or a subquery. So you don't have to tell us any extraneous information. Just tell us what data you're interested in. For the output schema, you do need to supply the name of the output type as well as the type, the name of the output column as well as the type. This is because your function can be acting as a transformation. You could be converting integers into strings, strings into integers. You could be outputting whatever. I mean, it's really up to you. So for the output schema, you provide both the column name and the type. The input can be a table, or it can also be the results of a subquery. I mentioned this because it's there's a bit of overhead involved in executing these JavaScript functions. As you can imagine, we have to take the data out of process, send it across a process boundary into a JavaScript interpreter, and then run your function. So there's not much in the way of network I/O. One of the neat things about this is that it actually executes in process, on the same hosts that BigQuery is running on. So you don't have this expensive round trip to get off the host into, say, like a Hadoop processing cluster and back. But there is overhead involved in processing JavaScript. So if you have the ability to filter down the data that you're wanting to act on before it gets in the JavaScript function, that can save you a lot of processing time. So here's the full function again. It's one of the things that I will point out is that, again, this is a beta feature. We're in the midst of polishing it up and getting some of the rough edges out. So at the moment, the entire query has to be, or your entire JavaScript function is defined inline in the query. We're working on an API that will make it easier to use and do things like use JavaScript libraries, have your code in source control, and then be able to pull it into the query more easily, and so on and so forth. But for right now, this is what it looks like. So let's take a look at how it's implemented. We'll peek under the hood a bit. If you remember the slide that Felipe showed you of the query execution tree, one thing that I'd like to point out here is that all of these colored boxes, the leaf nodes and the mixer nodes, are all doing effectively a similar job. They're taking data from the level below it, whether that's persistent storage or a query further down. They're applying whatever transformations need to be made on it, and then they're sending the results up. So they're all actually running exactly the same binary. They're just doing different levels of granularity in terms of the filtering, joining, and transformations. So if we pop open one of these boxes and look inside it, what we see is that the way that BigQuery handles data is it calculates the entire record of data or an entire row of data and then streams it up through something called a row iterator. Now, a row iterator does exactly what it says on the label, but that also happens to be a really handy place for us to plug in these user-defined functions. So any place that we have a row iterator, we have the ability to intercept that data and do stuff with it. So let's look at a concrete example of what this might look like. Let's say that you have a retail website, a retail store, and you want to join your order item information with web clicks, with your clickstream data, and try to get information about what sort of search terms are coming in that actually end up generating orders. Now let's say that your URLs look like this. So you have 7% 2E1 plus speakers. This is URL encoded data. Different kinds of data encodings can be kind of a pain to work with. What we actually want to do is extract and decode the query terms so that we have, aha, the user is looking for 7.1 speakers for their home. So we can do this with the user-defined function. I'll show you how the data flows around in this tree. Subquery 0 and subquery 1 start streaming their data. This can happen independently in parallel since it's a sharded distributed system. The rows of data get intercepted by our user-defined function here. The UDF starts streaming the data across a process boundary to an instance of V8, which is the JavaScript engine that's running in your Chrome browser. V8 has a relatively good C++ embedding API, which allows you to use JavaScript in your C++ programs. In this case, we take the rows of data, send them one by one through to the function that you define, get the results back. Those go to the UDF, go back to the UDF, and then get propagated up the tree, and so on and so forth. It would look very similar for the results coming out of the join if we needed to perform additional processing later on. So Felipe, I know that you like working with Wikipedia data here.
Yes.
You want to show us another cool example?
Let's try something else. So, I love analyzing Wikipedia's data. It changes hour by hour, month by month. Every language is different. You can really extract a lot of knowledge from it, and you can do a lot with SQL. But sometimes I run into problems.
So what if we wanted to answer a question like, who's the most important François or Françoise in the French-speaking world?
Okay, that's a trick question. Let's see how we could run the same SQL that we ran before, but looking for the most important Françoise. So the trick question here lies in a special letter, the cedilla, that takes us outside the ASCII domain. Unicode, BigQuery works with Unicode, so we can write a query like this on the French Wikipedia. That's why we have the language involved FR. We want to see every title that has a cedilla in it. Let's run it.
All right.
Let's see what we get. And yes, this time it only took 6 seconds.
That's not a lot of results though. It's kind of strange.
Yes, we are running with a CDIA, but we are not getting many results.
No.
In this case, we're going not over the whole of August. We're going only on a particular hour during October. But still, it's very few results.
Now, one of the things that's very powerful about BigQuery, and one of the reasons that I really like using it is because it's very fast. And this lets you play with your data. Maybe you don't always know what the right questions to ask are. And in a traditional data warehousing environment, sometimes what you would have to do is schedule your queries or work on a really small subset of your data, schedule your queries, and then come back a day later and say, oh, this doesn't tell me anything interesting. So if we had done this in a data warehousing situation, we'd come back tomorrow and say, this doesn't look right.
Yep.
So let's play with the data a bit. What if we just comment out the CDIA here so that we can see what the most popular French titles are?
Let's look at the whole French Wikipedia during this hour. And the results are in.
Look at that. So it looks like we have the same thing that we saw on the previous slide. We have some of this URL encoded data here.
Yeah, somehow some logs of Wikipedia are encoded, ASCII code, URL encoded, and some are not. So dealing with that is hard in SQL. What can we do about it?
Well, if BigQuery had a built-in function to deal with this, BigQuery does have quite a few built-ins to deal with string manipulation, but we don't have URL decoding. However, a function for URL decoding does exist in JavaScript.
And we can run JavaScript inside BigQuery.
Yes,
Excellent.
as of now. So that to save you from watching me type all this, I have this as a saved query here. What you see here is basically the query that I ran before. We're just selecting all of the French language articles from this particular hour in Wikipedia. And then here's our JavaScript function. So the function here is just using the JavaScript built-in of decode URI, which will do the URL decoding. And then after we decode it and merge it with the results that have a regular CDIA, we can do the filtering for where title contains the CDIA character.
Let's run it.
All right.
Let's see who's the most famous Francois or whoever has a CD in the title name. And
Interesting.
it didn't work.
Look at this. URI malformed at line 3.
That looks like a JavaScript error.
Yeah. Now, again, beta features, so our debugging information doesn't always exactly match up, but generally what I want to do in this situation is start counting from the beginning of the function declaration. So around line 3, I see that we have the decode URI function. So I think what's probably happening is some of our data is causing this to blow up.
Data is not always clean.
Yeah.
In fact, never. But
stuff happens, as they say. So,
so how do we deal with errors in JavaScript?
well, one of the things that we could do is use the speed of BigQuery to start digging through the data and try to find out what is causing this error. But as developers, we have a variety of tricks up our sleeves. And in this case, we are using the V8 engine and all of its features. So we have access to any language features in JavaScript that the V8 engine supports, including, in this case, try catch.
So we find an error, we try it, and we catch it.
Yep.
Yes. And when we catch the exception, we can just not decode the title.
Sure. So we'll just, apologies, I'm not going to okay, I will format this really pretty.
That's nice. JavaScript.
Okay, good enough. So if we catch an exception, why don't we just emit the title as is?
Without any decoding.
So quick survey here. Does anybody have a guess of who the most important or the most visited Francois is? Mitterrand? Okay, former French president. Anybody else? Bonnier? Okay.
Let's run it.
Let's see if catching this exception does fix our issue here.
So
now
I heard Mitterrand, I heard who else?
Hollande, the current French president, of course. So on a multi-tenant system, we find that queries it's hard for us to gauge exactly how long a given query is going to take because a large part of it depends on what else is going on in the system at that time.
Yeah.
There are certain things like shuffle resources, for example, that are shared with greater or lesser... well, anyways. So we see that during this hour in October, the François with the most page views is actually François Lenglet, the French journalist, who has gotten more than twice as many hits as François Hollande, le pauvre.
And who knew? The idea is that we can run these queries, we can discover this. If data is not clean, we can run JavaScript to decode it. We can run any other arbitrary query.
So why don't we see who the most important person with the Cedilla in the Walloon world is? So,
okay, let's switch language now.
So we'll look at Dutch.
Any guess? Will it be a François in the Dutch Wikipedia? The title with more...
With the most hits with the Cedilla.
With a Cedilla in.
This actually gets kind of addictive. Once you start being able to ask these arbitrary questions out of your data, it gets really exciting. You're like, what else can I find from this? What else can I discover?
Yes.
So the last one took about 30 some odd seconds. We should be getting a result back soon.
Yeah. Sometimes it's a multi-tenant environment that causes these variations, and sometimes it's just the connection. So as Steve Jobs says, can everyone turn off their Wi-Fi devices? Because sometimes that's the problem.
That's a joke, of course. Well, while this is running, here we go.
Yeah.
So in the Flamand or Dutch world, it looks like Curaçao is the most frequently requested page title with the Cedilla in it.
Yeah.
Okay.
So that's what we brought today. Thomas has a session tomorrow.
Tomorrow I'll be speaking with Martin Goner about Dataflow, which is a new one of the new additions to the Google Cloud Platform. That's basically an externalization of the Flume programming paradigm. So if you're interested in coming to see that, we encourage you to come check it out.
Yep. We have lots of ways to analyze data. BigQuery is the fastest and quickest and the least configuration you will ever need to analyze your structured data. If you want to know more about BigQuery, if you want to follow the news, we have a Reddit and Stack Overflow. We are always answering questions. There are a lot of interesting queries that you can share to in BigQuery.s. Thomas Park, a software engineer for the BigQuery project. I'm Felipe Hoffa. You can follow me on Twitter. And please, if you like this talk, give us a review at that link. And if you didn't like it, please go there and tell us why, because we just want to make a better presentation for you. Thank you very much.
There's one thing I will add. So currently we have this functionality in a kind of trusted tester limited preview sort of fashion. So if you are interested in using this, or if you have use cases for which this would be a great tool in your toolkit, please let us know, and we'll be sure to also put shout out on Reddit and on Stack Overflow as soon as this is available. Thank you very much.
Thank you. Yay.